Hello, my lovely students, grade 5 students, boys and girls. Hope you're all doing so well. In today's video, we're going to have a look at some very important concepts in maths that you've taken since the beginning of the year. And the first thing that we're going to talk about is place value of whole numbers. Before starting talking about place value, can anyone help me read this number, please? All right, I hear some of you saying it's 3,254,641. Very good. If you got this number, yes, it is right. Okay, but in this video, we're going to talk about two different things, place value and value. And there is a difference between place value and value. If we ask about the place value of the first digit that we have here, which is the 1, what would the answer be? Yes, the place value of the first digit is the ones. Okay, and the second digit, what's the place value of the second digit? And I want you guys just to remember that there is a difference between a digit and a number. Because here we have only one number, which is 3,254,641, but we have 7 digits. 1, 2, 3, 4, 5, 6, 7. 7 digits. So one number that consists of 7 digits. So the place value of the 1, we said that it's ones. And the place value of the 4 is, yes, tens. The place value of the 6, very good, hundreds. The place value of the 4, amazing, is thousands. You already took this in grade 3 and grade 4. The place value of the 5 is, yes, 10,000s. 10,000s. The place value of the 2 is 100,000s. Thousands. 100,000s. And the last digit here, which is the 3, the place value of the 3 is millions. Yes, very good. Millions. This is the place value. So if in the test you have a question asking you about the place or the place value of a certain digit, this is how you should say it. The place value of the 4 is tens. So what if they ask us about the value? The value of the 1 is, now you need to ask yourself, 1 once. So it's only 1. So in the ones, whatever that number over there is, just we put it down in the value. So 1, the value of the 1 is just 1 because it's in the ones place. The value of the 4 is, I hear some of you saying 4. No, it's not 4. It's 4 tens. What's 4 tens? Yes, fantastic. It's 40. So the value of the 4 is 40. And the value of the 6, yeah, 6 hundredths is 600. 4, if the place value of the 4 is thousands, so it's 4,000. And the value of the 5 here, if the place value of the 5 is 10,000s, so the value is, very good, 50,000s. If the place value of the 2 is 100,000s, so then the value is, fantastic, 200,000. And the value of the 3 is, yes, 3 million. Now we're going to leave this and go to the place value of decimals. The place value and value of decimals. And it's a little bit different here. Why? Because as you see, here we have a decimal point, which just separates the left side from the right side. The left side, the first digit here we have before the decimal point is the ones. Before the decimal point is the ones. So the place value of the 3 here is ones. The place value of the second digit before the decimal point is tens. The place value of the third digit before the decimal point is hundreds. And so on. After hundreds, if you have other digits, we just say thousands, 10,000s, 100,000s, and so on. So this is how we deal with the digits before the decimal point, the left side here. This is how we deal with it. All right. So what about the digits after the decimal point, Mr. Ahmed? Good question. The first digit after the decimal point is the tenth. Tenth ends with TH, then tenths. So the place value of the first digit is the tenth. Please try to memorize this. I don't want to see people saying the first digit after the decimal point is the ones. No. Or the tens. No. The tens that ends with S, the tens that ends with S is before the decimal point. Now we finished this. Now we're dealing only with after the decimal point. It starts with tenths. Then, yes, very good. Hundredths. Then 8. What's the place value of the 8? Very good. It's thousandths. So it starts with tenths, hundredths, then thousandths. If you have a number like this, the 5, a digit, sorry, the first digit, we said what's the place value of the 5? Yeah, oh, the place value of the 5 is the first digit after the decimal point, so it is tenths. So it's 5 tenths, Mr. Ahmed. 5 tenths. What does that mean? It means 5 over 10 as a fraction. Oh, you're talking about the value now, Mr. Ahmed. Yeah, I'm talking about the value. So the value of the 5 is 5 over 10 as a fraction. So as a decimal. The value of the 5 as a decimal is 0.5. Why? Because we said it's 5 tenths. Tenth is the first digit after the decimal point. So 5 is in the first digit after the decimal point. The second digit after the decimal point here is the 6. We said that the place value of the second digit after the decimal point is the hundredths. Amazing. So the place value, so the value here of the 6 as a fraction is, oh, Mr. Ahmed said it's 6 hundredths, so the value is 6 over, fantastic, over 100. 6 over 100. As a decimal, 6 hundredths. Mr. Ahmed said that the hundredths is the second digit after the decimal point. So I'm going to put here this decimal point. it's 0 point. The second digit, I wanted the 6 to be in the second digit. And like this, we read it, we say 6 hundredths. This is how we read it, 6 hundredths. Or you can just simply say 0 0.06. The last digit here that we have, it's 8. 8 what? 8 what? What's the place value of the 8? Mr. Ahmed said the first digit is the tenths, the second is the hundredths, and then it's the thousandths. So it's 8 thousandths. Yeah, 8 thousandths as a fraction means it's 8 over, very good, over 1000. And as a decimal, it is thousandths. Mr. Ahmed said the thousandths is the third digit after the decimal point, the third digit, so it's going to be 0 point. Yes, very good. 0, 0, 8. Now, what's the value of the 3? The value of the 3, it's the ones. It's just 3. As a fraction, it's 3 over 1, which is just 3. As a decimal, it's 3.0, which is just 3. What's the value of the 4? It's 4 tenths, which is 40. As a fraction, it's 40 over 1. As a decimal, it's 40.0. What's the value of the 2? It's 2 hundredths. 200. Which is as a fraction? Huh? Very good. 200 over 1, and as a decimal, 200.0. Very good. Now you understand the place value of decimals. We're going to move to another thing right now, which is comparing decimals. Yes. How can we compare decimals? In order to compare decimals, you need to look first at the left side of the number, which means all the digits before the decimal point. So here, I'm going to compare first the digits before the decimal point with the digits before the decimal point in the other number. What's the number here before the decimal point? Yes, it's 23. And the number here before the decimal point, very good, it's 18. Which one is greater? Excellent, grade 5. This is greater. You don't need to worry about after this. You don't need even to look at the digits after the decimal point. I don't want you even to look at this. Why? Because the first step is to compare the whole number here, is to compare the number or the digits that are before the decimal point. Here I have 23, here I have 18. I compare them. Both of them are equal, it's a different story, which is not the case here. But both of them are different. I check which one is greater, and that's it. This answers my question. Let's have a look at the second question here. 13.25 and 13.3. I can hear you, Farida, saying that 13 and 13, both of them are equal. Yes, very good. But Omar Abdullah Farid has an explanation. He says if the numbers or the digits here before the decimal point are the same or are equal, you just look at the first digit after the decimal point. So you look at the 2 here and the first digit after the decimal point here. It's only the first digit. Omar Abdullah Farid explained. So here it's 2 and here it is 3. So which one is greater? Yes, obviously it's the 3. So that's it. Oh, Mr. Ahmed, how? This doesn't make any sense. How come 25 is less than 3? Yeah, didn't Ali tell you that here, this 3, there is a hidden 0 here that makes this 30? Here we have 2 digits. If in order to compare this, we need also to have here 2 digits. So it's 30 and here it's 25. So this is greater. So in order to avoid the confusion here, you just look at the first digit after the decimal point and the first digit after the decimal point. If both of them are equal, I compare the second digit with the second digit. But here, both of them are different. 2 is less than 3. 3 is greater. So this number, 13.3, is greater than 13.25. The next question, 2.6 and 2.43. How can I compare these two numbers? Alright, Yasin is going to explain this, and he's saying, as Mr. Ahmed said, we need to compare this digit first, the digits before the decimal point with the digits before the decimal point over here. Omar Talab answered saying, alright Yasin, but both of them are the same, so how are we going to compare this? So does this mean that they are equal? Then Omar Ahmed just said to them, come on guys, don't you remember when Mr. Ahmed said that the 2 here, if the 2 digits before the decimal point are the same, we look at the first digit after the decimal point and compare them? 6 and 4. We compare both of them. Then Hannah said to him, yeah, I remember this. And he said that the 6 is greater than the 4. Then this number is greater and there is even no need to look at the second digit. And the whole class understood this from them. After that, Hala just wanted to make sure that she understands what they were talking about. So she wanted to answer the next question. She wanted to compare 0.25 with 0.4. She said, I'm going to follow the steps that they were talking about. And I'm going to compare the digits here before the decimal point with the digits before the decimal point in the other number. 0 and 0, both of them are the same, so they are equal. Then just Hassan entered the room and arrived at the right time and stopped Hala from ruining Mr. Ahmed's video by making such a silly mistake. And he said to her, come on Hala, don't you remember when Mr. Ahmed said 100 times in the class that we compare first the digits before the decimal number, before the decimal point, with the digits before the decimal point? If both of them are the same, you look at the first digit after the decimal point. Then Hala said to him, I already know this. And she started comparing the first digit number here, which is the 2, with the 4. She said that the 4 is greater than the 2. So she said that I'm going to choose this. That 0.4 is greater than 0.25 because the first digit after the decimal point here is greater than the first digit after the decimal point here. After that, Mustafa Badr wanted to answer the next question, and Mr. Ahmed chose him to answer the question. He said, I'm going to compare the digits before the decimal point first, and he did so and found that the digits before the decimal point are equal. Then he decided to move to the first digit after the decimal point, and he found that it is 3. And here it's 3, so both of them are the same. So Omar Ahmed just told him, why don't you just move to the next digit after the first digit? Then Mustafa Badr said to him, yeah, exactly, this is what I was thinking of. So he moved to the second digit to compare, and he found that it's 0, and in this other number here, it's nothing. But then Mr. Ahmed reminded them and said, what is nothing in maths? They said nothing is 0. Just only after the decimal point we can do this. So here you have a 0 and here you have a 0. So this number, these two numbers are equal. So yes, 0.30 is equal to 0.3. The last question here, Mustafa Bana wanted to answer it, and Mr. Ahmed gave him the chance to. So 10.2 and 10.20. Mustafa said, I'm going to compare the digits before the decimal point. So he compared 10 and 10, and he found that both of them are equal. Then the next step, which Jana did, she compared the first digit after the decimal point with the first digit after the decimal point here. And Jana said they are the same, 2 and 2. Then she decided to compare the second digit. She found that it's 0 here and nothing here. And also she remembered what happened in the question before, that nothing after the decimal point means 0. So it's 20 and 20. So they found out that 10.2 is equal to 10.20. This is everything about comparing decimals, and now we're going to move to a different thing, which is, let me check here. We have, yes, writing numbers in word form, in the word form. 23.18. And now Mustafa Amr hasn't answered anything yet. So he wants to answer this question and say how we can write 23.18 in word form. This is what he's going to do right now. Mustafa Amr said, okay, I'm just going to write 23 and, oh, so he remembers that Mr. Ahmed said the decimal point in the word form is and. So it's 23 and 18. 18 what? 23 and 18. Oh, he remembered another thing that is really important, and Mr. Ahmed mentioned to the class that if you want to give this a name, you just ask yourself about the place value of the last digit after the decimal point. So the last digit here, the place value of it, is that this is tenths and this is hundredths, so it's hundredths. Yes, so it's 23 and 18 hundredths. I'm just going to write the answer of the first number on it. 20, 3, and 18 hundredths. Very good. The second question. Who is going to answer the second question? Who is going to answer the second question? And Mr. Ahmed is going to choose Mariam Hadi. Mariam just read the number and she said 136.241. She decided to write it, to follow the steps, and wrote 136. The point is, she remembered that Mr. Ahmed said the point in the word form is and. So 136 and 241 thousandths. Why did she say thousandths? She said thousandths because the place value of the last digit here in the question is the thousandths. So yes, it's 136 and 241 thousandths. The third question here, and it's one of the boys' turn. Who are we going to choose? Are we going to choose here? Okay, we're going to choose Yahya. And Yahya said, there is nothing here in the whole number, so I'm not going to read anything. It's just only 3. All what I have here is 3. But is it a normal 3? Are you just going to write 3? No, it's 3 what? What's the place value of the 3? It's 3 thousandths. Yeah, perfect, Yahya. Good job. So it's 3 thousandths. After that, Mahmoud wanted also to answer, so he took the next question, which is 0.06, and he said it's 6 tenths. 6 tenths. All right, then the question after is 0.6. And who's going to answer this question? It's Khadija, and Khadija said it's 6 hundredths. 6 hundredths. Then we have here 4.16. And 4.16, Who's gonna answer this question? And one of the girls just kept saying me, and Mr. Rahmat chose her, and it is Hagar. Hagar said 4.16. It is 4, and the point is in the word form is and, so it's 4 and 16 hundredths. Why? Because the digit of the place value of the last digit here is the hundredths. So it's 4 and 16 hundredths. All right, very good. The next question here is write in the expanded form. To write these numbers in the expanded form. It's 12.306, or we can say 12 and 306 thousandths. How can we write it in the word form? We take it digit by digit. You can take the 2. What about the 2? What's the place value of the 2? Yes, the place value of the 2 is the ones. So it's 2, open bracket, 2 times 1 plus, this is the expanded form. What about the 1? It's tens, Mr. Ahmed. Yeah, very good. Because Mr. Ahmed said in the first part of the lesson that the place value of the first digit before the decimal point is the ones, and the place value of the second digit before the decimal point is the tens, and so on. So here the 2 is the ones, 2 times 1. The 1 is the tens, it's 1 times 10. Then what about the 3? Oh, Mr. Ahmed said that the place value of the 3 is, yes, tenths. So in order to write the expanded form, you need to know the place value of each digit. So the place value of the 3 is tenths. So it's 3 times tenths. What's a tenth? Yes, it's 1 over 10. Plus, what's the place value of the 0? It's a 0. It's not gonna, we don't really need to worry about it. Then we have here a 6. What's the place value of the 6? Yeah, I hear some of you saying thousandths. So the place value of the 6 is the thousandths. So it's 6 times thousandths. What's thousandths as a fraction? It's 1 over 1,000. That's it. The second question here that we have is 42.024. 024. And who's going to answer this question? Yes, I'm going to choose Khalid. And Khalid said that it's 42 and 24 thousandths, Mr. Ahmed. So I'm going to take the 2 first, which is the ones. So I'm going to say it's 2 times 1. And then Khalid continued saying, then I have 4, which is the tens, which is 4 times 10. After that, Omar al-Khatib wanted to continue. And he said, the 0, Mr. Ahmed, I'm not going to worry about it, because it's just a 0. In the expanded form, it's not going to really make a difference. But the 2 here, what am I going to write about the 2 over here? The 2, Mr. Rahmat said that I need to ask myself first what place value the 2 is. And Mr. Rahmat said the second digit after the decimal point is the hundredths. So it is 2 times hundredths, which is 1 over 100. Then Mr. Rahmat said about the 4, which is 4 thousandths. Omar Khatib is saying so. So it's 4 times thousandths, which is 1 over 1,000. And this answers the question. The last 2 questions that we have on this page over here, the first one is about writing in the standard form. Standard form is like what we have here. This is a standard form. 4.16, this is written in the standard form. 0.6 is the standard form. 0.06 is the standard form. So please just remember that this is the standard form, this is expanded form, and this one here on the top is the word form. This is the word form. And the last questions here, the last 2 questions are asking you to write them in the standard form. So Maram is going to answer this question, and it's just saying 2 times 1, that means that 2 here is in the ones place. So 2 is in the ones place. And 4 times 1/10, 1/10, this means here that there is a decimal point. And the 4 is in the first digit, after the decimal point because it's in the tens place. And then it's 6 times 6 times 1 over 100, which is 6 times hundredths, 1/100. So it means that 6 is in the hundredths place, which is the second digit. The second question here, and Mr. Ahmed chose Hassan Khalid to answer the question. Hassan Khalid said 3 times 10. This means that 3 is in the tens place. So he put the 3 in the tens place. And after that, he found that it's 5 times 1 over 100, means that 5 is in the hundredths place. He got a little bit confused over here. Then who helped him? He had Omar Yasser helping him. Omar Yasser just told him, all right, you know what? If we have tens, a digit in the tens place, there must be a number in the ones. But Hassan Khalid then replied saying, okay, but there is nothing here in the ones. Oh, if there is nothing in the ones, Mr. Ahmed, that said that nothing in maths is 0. So I think this is what we should have here. 0 is in the ones because we have 3 in the tens. We need something in the ones. All right, then Hassan Khalid agreed. Then who got involved? They got who hasn't answered yet? Who hasn't answered yet? They got Omar Talal. And Omar Talal said this to them, the next step is the 5. And he said that the 5 is in the hundredths place. So we need to have a decimal point and to put the 5 in the hundredths place. But then Hassan Khalid reminded him, how can we jump to the hundredths place without finishing the tenths? So Hassan suggested, since there is nothing here about the tenths, so it's 0. Because there is nothing here about the tenths. And Omar Yasser and Omar Talal agreed. Then Muhammad Bilal decided to join them. And he said to them, guys, we have here the 4 left. And Muhammad Bilal said that the 4 is in the thousandths place, and the thousandths is the third digit after the decimal point. Here he's going to put the 4 in the thousandths place. So in this page, you learned how to change or turn an expanded form into the standard form, and the standard form into the expanded form, and the standard form into word form. What do we have next? Oh, a lesson that all of you really like. Prime factorization. In prime factorization, Muhammad Ragab is going to tell us the difference between prime numbers and composite numbers. Muhammad Ragab just said, prime numbers are numbers that are divisible only by themselves and 1. How? Like the 2. If you want to divide the 2, Mr. Ahmed, you can just divide it by itself, by 2 and only by 1. And the 3 can be divided only by itself, 3 and 1. So nothing goes into the 2 but itself and 1. So 2, 3, 5, 7, 11, 13, 17, 23, and so on. All these numbers are called prime numbers because nothing can go into them but themselves and 1. So that's why we call them prime numbers. Then he continued saying that composite numbers are the opposite. A composite number is a number that has factors other than 1 and itself, like the 4. We have many numbers, or more than one number or 2 numbers that can go into 4. We have 1 can go into 4. We have 4 itself can go into 4 at one time, and we have also 2. So 4 is divisible by other digits. 4 is divisible by 2, is divisible by 4, is divisible by 1. So 4 is a composite number. The 6, there are numbers that go into 6 with the 1 and the 6 itself, which is 2 and 3. 2 goes into 6 3 times, and 3 goes into 6 2 times. 4, 6, 8, 9, 10, 12, and we have 27 and 32, and we need to prime factorize them. So Yassine wanted to answer this question. He loves a prime factorization. So Mr. Ahmed gave him this question. And he said, Mr. Ahmed, 27, if I want to prime factorize it, I'm going to choose 9 and 3. So Yassine chose 9 and 3. He said 9 times 3 give me 27. Then, who helped him? Mustafa Amr just said to him, alright, 9 times 3, yes, they give us 27. The 3, we cannot prime factorize it. Why? Because it's already a prime number. It's a prime factor here. So we're just gonna underline it like this. And then Yassine said to him, alright, then the 9 here, if I want to continue, I can continue because it's a composite number. And the idea of prime factorizing is just to have in the end all of the underlying digits, the underlying numbers to be prime numbers. So the 9 is, no, I'm sorry. It's Yassine's mistake, not my mistake. Where is my rubber? Where is my rubber? Oh, here it is. We're not going to underline this. It's a composite. It's a composite number. Come on, Yassine. It's a composite number. We cannot underline it. Then Yassine said that it's going to be 3 times 3. And the 3, I cannot continue after this. I cannot continue after this. So what are the 3 prime numbers that we have? It's 3 times 3 times 3. We have a different question here, 32, and Lena is going to answer this question. Lena said 32 is what times what? She kept thinking until she found that 32 is 4 times 8. Yes, 4 times 8 is 32. Then, who's going to help her? Jumana. Jumana said that the 4 here is not a prime number, so I need to factorize it. And she said that the 4 is going to be 2 times 2. And then she continued saying, the 2 here, I cannot do anything to it. So I'm going to underline it. And the other 2 we have here, I cannot do anything to it as well. So I'm going to underline it. Who joined them? We have Judy. Judy joined them and she said that she's going to do the 8. And she said the 8 is going to be 4 and 4. And then Farida Muhammad joined them and said that this 4 is not prime, so she needs to factorize it more, and she said it's going to be 2 and 2. And the other 4 here is 2 and 2. And she underlined all the prime factors. Then Farida Muhammad said to Judy and to Lena that she's going to write all the prime factors here. 2 times 2 times 2 times 2. Oh, and then we have 1, 2, 3, 4. And then we have 2 more here. Times 2 times 2. Alright. This is everything about prime factorization. There is another video that is coming soon, inshallah. But till then, your homework is to answer all the questions that are in this video and to find the mistakes that I made in this video. So there are around 4 mistakes, I guess, maybe, or 3. I want you to tell me about the number of mistakes that I made in this video, and I want you to correct them as well. Thank you so much, grade 5, and have a nice day.